Hello friends, welcome to True Event Academy. In the last lecture, we have discussed up to question number 7. So we will discuss question number 8 onwards in this particular lecture. So what is given in the question is that a heavy particle hangs by a inextensible string of length A. Okay, so there is a heavy particle which is getting hanged from a fixed point. Okay, by through a light inextensible string. So length of the string is A. Okay, and is then projected horizontally with a velocity given as u is equal to root under 2gh. Okay, so it will carry out a circular motion like this. So what is given in the question is that if pi a upon 2 is greater than h greater than a, prove that the circular motion ceases when the particle has reached the height of a plus 2h upon 3. So let us consider this angle as a theta 1. So what we have to show is that the circular motion ceases when it reaches a height of a plus 2h upon 3 from the point of projection. Okay, so in the first part we have to show this. That is, here the circular motion ceases. This means tension in the string will become 0. Okay, and we have already seen in the various cases that when the tension in the string becomes 0, it will loses the circular motion. It will loses the circular path and carry out a parabolic path like this. That is a projectile motion. Okay, so projectile motion starts from the point where the string becomes slack, that is tension becomes 0. So at this particular point um, it will leave the circular path. Okay, that is that is the circular motion ceases to exist. In other words, okay. So let us find this. So we know that the velocity and tension at random theta is given by, okay, suppose let us consider a circular motion like this. Okay, so at a random theta, what will be the tension and the velocity if the initial velocity is u? So the tension is given by mu square upon a minus mg 2 minus 3 cos theta, and velocity is given as v square is equal to u square minus 2ag 1 minus cos theta. Okay, so let us consider this angle as theta 1. So let at theta is equal to theta 1, circular motion ceases. That is tension is equal to 0. So let us consider this as equation 1 and equation 2. So in equation 1, t is equal to 0 when theta is equal to theta 1. So the equation 1 becomes 0 is equal to m upon a into value of u square is 2gh minus mg 2 minus 3 cos theta 1. Okay. So this is 2 mgh upon a is equal to mg 2 minus 3 cos theta 1. Okay. So this mg gets cancelled. So we have 2 minus 3 cos theta 1 is equal to 2h upon a. So 3 cos theta 1 is equal to 2 minus 2h upon a equal to 2a minus 2h upon a. So cos theta 1 is equal to 2a minus 2h upon 3a. Okay, so we have the restrictions given as pi a upon 2 is greater than h greater than a. So we have pi a greater than 2h greater than 2a. This means 2a is less than 2h. So this particular numerator will be negative. Therefore, cos theta 1 is equal to negative. Okay, cos theta 1 is negative means theta 1 varies from pi by 2 to pi. Okay, so our assumption is correct. This means the circular motion ceases between the theta is equal to pi by 2 and theta is equal to pi. So between theta 1, between this value from here to here, between theta is equal to pi by 2 is this one and theta is equal to pi is this. Okay, so between theta is equal to pi by 2 and theta is equal to pi, circular motion ceases. That is tension is equal to 0. Now we have to calculate this height. What we have to find is that at a height of a plus 2h upon 3 from the bottom, from the point of projection, the circular motion ceases. Okay, let us find this. So we have the cos theta 1 as 2a minus 2h upon 3a. So we have cos theta 1 is equal to 2a minus 2h upon 3. Okay, so let us find this. So we have this value theta 1. Okay, so we have the projectile motion like this. Okay, this will be the velocity of the projectile because projectile is starting from this particular point. Let us consider this as B, this as A, this as O. Okay, so we have to find this particular height. Okay, so let us name this as C. So let us consider this triangle OBC. So we have this angle as theta 1. So this angle will be pi minus theta 1. Okay, so this angle will also be pi minus theta 1. So we have BC is equal to OB. BC is equal to OB cos of pi minus theta 1. So this is equal to OB is A. Okay, so this is equal to A times of minus cos theta 1. So we have A times of minus cos theta 1 is, so this is cos theta 1. The minus cos theta 1 will be 2h minus 2a. The 2h minus 2a upon 3a. So this gets cancelled is equal to 2h minus 2a upon 3. BC is equal to. Okay. So this whole height will be whole height. So the height of B from point of projection is equal to BC plus OA is equal to 2h minus 2a upon 3 plus a. So this is equal to 2h minus 2a plus 3a upon 3. Okay, so this will be equal to um, this is equal to a plus 2h upon 3. This is height. Okay, let us calculate further. In the second part, what we have to show is that prove that the greatest height ever reached by the particle before the point of projection. Okay, so let us calculate this. Second part, we have cos theta 1 is equal to 2a minus 2h upon 3. What we are having is that the circular motion ceases at a height of a plus 2h upon 3. Okay, so our projectile motion is like this. Okay, and this is the maximum height. Let us consider this. Okay, so let us name this. So what we have to find is that prove that the greatest height ever reached by the particle above the point of projection. So this is the greatest height. This is the greatest height. So this we have to find this height from the point of projection. Okay, so we will add a plus 2h upon 3 with, let us name this as P and this is as M. So MP we have to find. Okay, so MP is equal to, let us consider the velocity v1. V1 is the velocity at the starting point of the projectile motion. Okay, so what we have to find is that v1, and after that we have to find mb. So mb is the greatest height is given as, how we can find the greatest height? Suppose this is projectile, this is our initial velocity, so this height is the greatest height. Okay, suppose the angle is alpha, so we have height is as u square sine square alpha upon 2v. So in this particular case, what we will have v1 square sine square. So this angle is, this is theta 1, so this is pi minus theta 1. So this angle will also be pi minus theta 1. Okay, let us consider this as alpha. Okay, so we have sine square alpha upon 2g. This will be equal to v1 square sine square pi minus theta 1 upon 2g. mb is equal to. Okay, so let us find v1. So what, from the velocity, the final velocity is given as v square is equal to u square minus 2g 2ag 1 minus cos theta. Okay, so at we are having theta as a theta 1. So at theta 1, we have to find the velocity. So we have v1 square is equal to initial velocity is 2gh minus 2ag 1 minus cos theta 1. So cos theta 1 is cos theta 1. Let us put the value of cos theta 1. So v1 square is equal to 2gh minus 2ag 1 minus 2a minus 2h upon 3a. So we have v1 square is equal to 2gh minus 2ag 3a minus 2a plus 2h upon 3a. This is equal to v1 square is equal to 2gh minus 2ag a plus 2h upon 3a. This gets cancelled. So we have this as 2g common, h minus a plus 2h upon 3. Okay, 2g common, then we have h minus a plus 2h upon 3. This is equal to 2g into 3h minus a minus 2h upon 3. This is equal to v1 square is equal to 2g upon 3 h minus a. Okay, this is our velocity. So v1 is equal to root under 2g upon 3 h minus a. So now let us calculate the height. So we have the height as mb is equal to 1 upon 2g into v1 square is 2g upon 3 h minus a into this is sine square pi minus theta 1. So sine pi minus theta 1 is sine theta 1. So this is sine square theta 1. Sine square theta 1. Sine square theta 1 is equal to 1 minus cos square theta 1. So this is equal to 1 minus this cos theta 1 we can write as 2 upon 3 a minus h upon a. This is 4 upon 9 a minus h upon a ka whole square. Okay, so this gets cancelled. So we have h minus a upon 3 into 9a square. Okay, minus 4 times of a square minus 2ah plus h square upon 9a square. Okay, let us further simplify this. So we have mb is equal to h minus a upon 3 into 1 upon 9a square into 9a square minus 4a square plus 8ah minus 4h square. This is h minus a upon 27a square. 5a square minus 8ah minus 4h square. mb is equal to. Okay, so let us further simplify this. This is just calculation. mb is equal to h minus a upon 27a square into 5a square. This is 5 for the 20. So we will have minus of, sorry, this is plus, no? This is plus 5 for the 20. So 10 into 2. So this is the 10ah minus 2ah minus 4h square. So this is equal to 5a common a plus 2h minus 2h a plus 2h. This is 5a minus 2h h minus a upon 27a square into 5a minus 2h into a plus 2h. mb is equal to. Okay. So this mb, sorry, mp is equal to mp. This is mp. Okay. So the total height will be mp plus a plus 2h upon 3 is the total height. That is height from the point of projection. Let us further simplify this. height from point of projection. Point of projection is MP plus is equal to MP plus A plus 2H upon 3. So this is equal to H minus A upon 27 A square into 5A minus 2H into A plus 2H plus A plus 2H upon 3. Let us take common. So A plus 2H common. Okay. Upon, let us take this also common. 27 A square into 9 A square plus H minus A into 5A minus 2H. Okay. H minus A into 5A minus 2H into this. And this will be A plus 2H upon 3. So let us do the simplification. Equal to A plus 2H upon 27 A square. Okay. Into. If you simplify this, it will come 4A minus H into A plus 2H. Okay. On simplification. So we have this as A plus. So we have 4A minus H into A plus 2H का whole square upon 27 A square is the height of the particle from from the point of projection. Point of height of highest point. HIGH. Highest point of the particle from point of projection. So this is the height of the particle. Okay, so in the projectile motion we have calculated this particular height. Okay, so this is MP, and from the point of projection we have to find, so we will add this particular distance in this height of the projectile. This is MP, and this particular height is MP plus A plus 2H upon 3. So this is the total height that is required in the question. Okay, now let us solve question number 9. Okay, so what is given in the question? A particle is projected along the inside of a smooth fixed sphere from a lowest point. Okay, this is the sphere from the lowest point with a velocity equal to that due to falling freely down the vertical diameter of the sphere. So this is the vertical diameter. How we find the velocity? The velocity is given by 2g into height. Okay, so net height will be, this is the vertical diameter. So this is 2a. So what will be the velocity? Initial velocity is 2g. Sorry, it is root under 2g into 2a root under. So this is equal to 2 root under ag. Okay. Initial velocity is 2 root under ag. U is equal to root 2 root under ag. Okay. Particle is projected along the inside of a smooth fixed sphere from the lowest point with a velocity equal to that of v falling down from the vertical diameter. So that the particle will leave the sphere and afterwards pass vertically over the point of projection at a distance equal to 25 upon 3a of the diameter. So what we have to show is that, so suppose the particle leaves the sphere at an angle of theta 1. After that it will follow a, because the reaction becomes 0 here at an angle of theta 1, the reaction becomes 0. So after that it will follow a parabolic path like this. Parabolic path like this. Okay. After that it will, as per question, it will pass vertically over the point of projection. So it will follow a path like this. So we have to calculate this particular height. Okay, so this is a parabolic path. V1. Okay, so this particular angle will be, let us consider this angle as alpha. So alpha is equal to pi minus theta 1. So this will also be pi minus theta 1. Alpha is equal to pi minus theta 1. Okay, so this is our parabolic path. This is a trajectory, basically trajectory. Okay, so let us calculate the um, particle will leave the sphere after that. Okay, so let us calculate the value of theta 1. So we have the reaction R is given as mu square at a random theta. Reaction R is given at mu square upon A minus mg 2 minus 3 cos theta. Okay, so let at theta is equal to theta 1, R is equal to 0. So 0 is equal to m upon A into u square. U square is equal to 4ag minus mg 2 minus 3 cos theta. Okay, so we have this as 4 mg is equal to mg 2 minus 3 cos theta. Okay, this gets cancelled. So we have 2 is equal to minus 3 cos theta 1. So cos theta 1 is equal to minus 2 upon 3. Okay, the cos theta 1 is minus 2 upon 3. So now we have to find the value of V1. So V1 square is equal to initial velocity square u square minus 2ag 1 minus cos theta 1. So we have V1 square is equal to u square. This is 4ag minus 2ag 1 plus 2 upon 3. So this is equal to V1 square is equal to 4ag minus 2ag into 5 upon 3. Okay. So this will be equal to V1 square is equal to 12 minus 10. This is 2ag upon. Okay. This will be 12 minus 10. So 2ag upon 3. V1 square. So V1 is equal to root under 2ag upon 3. Okay. So let us find the equation of trajectory. Cos theta 1 is equal to minus 2 upon 3. Let us write this. Cos theta 1 is equal to minus 2 upon 3. Cos alpha is equal to cos of pi minus theta 1. This is equal to minus cos theta 1 is equal to minus of minus 2 by 3. This is 2 by 3. This is cos alpha. Okay. Okay. Let us find the equation of trajectory. So y is equal to x tan. So we have, let us consider this as alpha. Alpha is equal to pi minus theta 1. So x tan alpha minus gx square upon 2 v1 square cos square alpha. Okay. So let us find this. So we have cos alpha as 2 upon 3. So we have this is 2, this is 3. So this will be 9 minus 4 root under. So this is root under 5. So cos alpha is equal to 2 upon 3. Sin alpha is equal to cos alpha b upon h b upon. So root under 5 upon 3, or tan alpha is equal to root under 5 upon 2. So we have y is equal to x tan alpha. X into root under 5 upon 2 minus gx square upon 2 v1 square. So 2ag upon 3 into cos square alpha. Cos square alpha is 4 upon 9. Okay. So this g gets cancelled. So we have y is equal to x root under 5 upon 2 minus 9 3 is 27 x square upon 4 4 is 16a. This is 2 to the 4, 4 to the 4 4 16 into a. Okay. So we have to find this distance. Okay. So we have to find this distance. So this is alpha. So this will also be alpha. Okay. So this distance will be a of a sin alpha. Okay. So the coordinate of point will be what we have to find is that show that the particle will leave the sphere and afterwards pass vertically over the point of projection. Okay, so let us find this. Okay, so what we are having is that at this particular point, let us consider this as this is theta 1. So here the projectile motion starts. So V1 is equal to 2gh upon 3. Sorry, 2ag upon 3. Okay, so this angle is alpha. This angle is also alpha. Is equal alpha is equal to basically pi minus theta 1. This angle is also alpha. So this distance will be a sine alpha. Okay, so the projectile motion passes vertically over the point of projection. The projectile will pass from here like this. This is our projectile motion. It will pass vertically over the point of projection. So we have to find this particular distance. Okay, so this horizontal distance of this point, let us consider this point as k. Okay, so the coordinate of k will be, and this is our point of reference. Okay, so from with reference to point B, the coordinate of q with respect to point B is equal to, so this is equal to this direction we are taking as positive, this direction as negative. So this point K is below this point B, so y coordinate will be negative. So we have this as x coordinate as a sine alpha. So this particular point K is at a distance of a sine alpha from point B. So a sine alpha, so this is positive, and this distance will be, let us consider this as y1. Okay, so this is y1. So this will be negative. So what we have to find? We have to find y1. Okay, so y1 will be the distance of this point from point B. Okay, so let us find this. So how we will find? Since this is lying, this point K is lying on the equation on the trajectory. So the coordinates of point K will satisfy the equation of trajectory. So this is the equation of trajectory. If we put value of a sine alpha in this particular expression, we will get y1. So let us put this. So we have y1 is equal to root 5 upon 2 into x. X is a sine alpha. Sine alpha is root under 5 upon 3. So a times of a sine alpha. Let us put first, we will put a sine alpha minus 27 upon 16a into a square sine square. Okay, so we have root under 5 upon 2 into a into root under 5 upon 3 minus 27a upon 16 into sine square alpha. So this is equal to 5 upon 9. Okay, so let us further simplify this. 5a upon 6 minus 9 3 ja 27. This is 15a upon 16. This is equal to 5a common, 1 upon 6 minus 3a upon 16. Sorry, 3 upon 16. This is equal to, let us take 2 common, to 5a upon 2, 1 upon 3 minus 3 upon 8. So this is equal to 5a upon 2 into 8 is 24, 8 minus 9 minus 1. So this is equal to minus 5a upon 48. This is y1. Now what we have to find? This y1 is equal to 5a upon 48. So we have to calculate this particular distance. Let us find this. I will draw this again. 5a upon 48. y1 is equal to 5a upon 48. So we have y1 is equal to 5a upon 48. What we are having is that, so our motion is a projectile motion from the point when it seizes when the circular motion gets seizes. Okay, so here from at this particular angle theta 1, reaction becomes 0. Okay, reaction becomes 0. So the circular motion ceases to exist and rather it will follow a parabolic path. Okay, it will follow a parabolic path and passes vertically over the point of projection. Okay, so this is our point of projection. So we have calculated y1. This is y1. Sorry. This is axis of the parabola. Okay, so we have calculated this particular distance y1. Okay, and so how we can find this? So this whole distance will be this distance. This distance is this is alpha. This is also alpha. So this distance will be a cos alpha. Okay, and this distance is a. So this whole distance will be a plus a cos alpha. Okay, and this is y1. So the height of particle from bottommost point that is point of projection is equal to this whole distance a plus a cos alpha minus y1, so minus 5a upon 48. So this is equal to a plus a into cos alpha की वैल्यू minus 2 by sorry plus 2 by 3 into 2 by 3 minus 5a upon 48. So this is equal to 5a upon 3 minus 5a upon 48. So this is equal to 48 into 16. Still 3 here. It is 16 minus 1. 5a into. Okay, so this is 5a into 15 upon 48. Okay, this is 16. This is 5. This is 5. 5 3 jato. This is 3 into 16. Okay, so this is equal to 25a upon 16. Okay, so let us multiply this with 2 and 2 at the top and the 2 at the bottom. 2 at the top and 2 at the bottom. So this is equal to 25 upon 32 into 2. So this is the diameter. So this is equal to, so the height is equal to 25 of 32 into diameter. Okay. So that the particle will leave the sphere and afterwards pass vertically over the point of projection at a distance of this distance is 25 by 32 into diameter. Diameter is 2a. Okay. We will discuss further questions in next particular lecture. Thank you.